देखती हैं हम और कितने कलर मिलेंगे। तो सबने कहा व्हाइट वो सब नहीं होना चाहिए, व्हाइट काली वाली निकाल दो जो है। जो कमल सर तो व्हाइट पहने हुए थे वो शुक्ला जी कोट पहने हुए थे, कोट के ऊपर नीली पहने हुए थे। कोट पहनना, कोट गर्मी गर्म ठंडा चेंज हो जाता है। हाँ? कलर चेंज कर देते हैं बहुत से। माँ ये कोई फिल्म की शूटिंग थोड़ी ना हो रही है तो तुम्हें यही कोट पहन के आना है। ये क्या है? Good morning, learners and viewers. First of all, I will introduce myself. I am Engineer Ashlesh Saxena. I am an academic counselor for quantitative analysis for managerial applications. That is the course for MBA program. Today, we will discuss block 1, which is related to data collection and analysis. And under that, we have 4 units. Unit 1 comprises of collection of data for MBA program. Facts expressed today we will discuss can be termed as data, which is related to data collection and investigation. Depends on the availability of accurate and reliable data. These depend on the appropriateness of the method chosen for data collection. That is why data collection is a very basic activity in decision making. Data is classified, can be classified in 2 forms. The first one is primary data, and the second one is secondary data. If we talk about primary data is the data which is collected specifically for the objectives of the study. Data collection is under the control and supervision of the investigation for the very first time. On the other hand, secondary data is the data which is not collected specifically for the objectives of the study, rather derived from records, registers, journals, reports, theses, etc. What are the different types of methods for data collection? First one is observation method, and the second one is questionnaire method. Observation method, here the investigators ask number of questions. He only observes and records. For example, we can say that recording of number of health service providers, retail outlets, educational institutions, etc. in a locality. Here, the accuracy of data can be a difficult task. There may be an error in recording or observations due to physical barriers, or we can say that. Second method is your questionnaire method. It is more widely used method in marketing and social development research. It is done through preparation of questionnaire, that is incorporating questions relevant to the objectives of the study, administration of the questionnaire, and through personal interviews by mail or telephone. As far as personal interview is concerned, it is between two. It is basically a conversation between two persons, that is the investigator and the respondent. Here, the information which is gathered is more accurate, or we can say that it's more accuracy is there, it's reliable. Cross checking and clarification of doubts is easy over here, and no doubt we have fine tuning between the investigator and the respondent. As everything has merits, demerits are also there. It is time consuming, it is costly, and large number of respondents are taken and they are widely distributed. Second method is mailing a questionnaire. Here, same thing is there, and the investigator is there, and a respondent. But this has some requirements. Respondent must be illiterate. One should have the ability to understand the instructions and questions and then answer them. It is easily adopted. When geographical area is large, respondents are widely spread. Second one is your telephonic conversation. That means there is an investigators and respondents. The requirement for this is you should have a phone facility. Merits are it's less expensive, we can call anybody, and we get instant responses. Similarly, demerit is on a phone call we cannot ask large number of questions. That means we have to be specific in asking the question, and no doubt limited number of respondents are there. Questionnaire method is an efficient method, and it can be said that it is fast also, but it has limitations. It is difficult in obtaining the information on ethical and sensitive issues. For example, income, disease history, personal life details. Nobody will be interested, and nobody will be liking to share all these informations on an open platform. And there are chances and fallacies in recording of the responses due to variation in understanding of respondent and investigator and interpreting in a wrong way. Now, how to design a survey? As designing, initially we have to start with designing of a questionnaire. It's pre-testing and editing the primary data. So we will discuss one by one over here. How designing a questionnaire is done. So we have to have a covering letter, which includes the introduction, objectives, instructions, consent. And as number of questions are concerned, the questions should be simple, short, and ambiguous. We should avoid technical, ethical, sensitive, or personal questions. No calculations should be there, and they should be logically arranged. When this information is available, there is the second step is pre-testing a questionnaire. In this, a pilot survey is done. Rectification process is done. Problems, inconsistencies, repetitions of the questions, etc. is taken care of. It is found out that no such information is repeated in any format. It helps in changing if some changes are required. Deletion of irrelevant questions can be done. Inclusion of check or instructions can be provided. And assessment of time in administration is there. The editing of primary data to make it its completeness in all respect, each and every question has to be taken care of. We have to see the consistency, that the response should not be contradictory. Accuracy, we have to check the accuracy of the obtained information. For checking accuracies, random cross-checks can be made. And regarding homogeneity, understanding of questions should be same in which they are perceived. For example, income, it can be weekly, it can be monthly, or it can be annual. Ambiguous questions may provide irrelevant information. What are the sources of secondary data? It can be through a published source, such as national organizations, CSOs, NSSO, Office of Registrar General, FICCI, ICAR, etc. These are national. And if we talk about international organizations, it can be UNO, WHO, ILO, World Bank, etc. Apart from published source, data, secondary data can be is also available in unpublished sources. That is, all statistical data has to be published. Major source for that is government and semi-government, private and public organizations, payrolls, cash books, transaction data, etc. What are the precautions to be taken for the use of secondary data? We should not accept the data at its face value. Now the question is why? Because data may be full of errors, because of bias, inadequate sample size, non-representative and purposive sample, computational errors. We should focus on suitability because we are acquiring this by secondary data. So we should, as far as suitability is concerned, it should be suitable for the purpose of study or inquiry. That means we have to judge the nature and scope of the study. Second one is reliability of the source. We have to determine the reliability of the data and unbiasedness of the data. We have to judge the accuracy of the agency which is providing the data from where we are taking up the data. Credibility of the source, whether the data provides entire gamut of information or a part of information under the study. Data collection through original investigation. When secondary data is not available for the problem under study, a decision of primary data collection through the original investigation is suitable. There are two methods which are available for the data collection. The first one is Celsius, that is complete enumeration method, and the second one is sampling method. When we talk about Celsius method, when investigator collects data by covering each and every unit of the total population, this method is known as complete enumeration or Celsius. For example, all males and females, all males or females or all children, all households or all business houses or agencies, all retail outlets or dealers or publishers. Merits for Celsius method is that the information is about every unit what we are considering, and it's more accurate, real, and consistent. This has demerits also. It is not viable economically. It is time consuming and quality may suffer. If we talk about sample method, when investigator collects data by covering only a representative part of the total population and makes inference about the total population, this method is known as sampling method. Sampling method has merits because the representativeness is for the entire population. It is time saving and it yields correct inferences. Now we move on to unit 2, that is how the presentation of data is done. In unit 1, we collect the data. Now in unit 2, we will discuss about the presentation of the data. After data collection, data needs to be used properly. For this, data should be arranged, displayed, or summarized in a perfect manner. The presentation of data can be done by following. Data can be displayed either in tabular form or through charts. That is the easiest way to interpret it and to understand. For tabular form, Data needs to be classified before it is tabulated. That means classification of data or charting of data. What are the objectives of classification? Condense the mass of data so that salient features can be noticed. Facilitate comparison between attributes and variables. Prepare data to be presented in tabular form and highlight the significant features of the data at a glance. What are the different types of classification? There are four basic types of classification. The first one is geographical. The second one is chronological. The third one is qualitative. And the fourth one is quantitative. If we talk about geographical, it is related to area, region, or place. Chronological order means occurrence of an event. Qualitative, it is related to attributes. And quantitative is related to magnitudes or numerical values. Now we will take up an example. What are the how this classification is done? If we talk about geographical, so it can be its example can be a production of rice country-wise. If we talk about chronological, it will be a sales figure of a company year-wise. Now, if we talk about qualitative part, so it can be how to classify population on the basis of education. And the fourth one, that is quantitative. It is number of vehicles in cities of Hyderabad. These are the basic examples. Now we move on to how the frequency distribution or how the data is, these numbers are converted into data. We will start with frequency distribution. It is arrangement of data in groups or categories. Raw data is presented by distinct groups, which is known as classes. And the number of observations that falls under each class is its frequency. Discrete frequency distribution, we start with discrete frequency distribution. In this, we have to place all figures in ascending order. And then we make up the tally marks to count the numbers. So this is how. If we talk about number of children of a family, so we can say that we are talking about some quantity of families. So we can convert that. Families with 0 children, there are 3. So families with 1 children, there are 8. Families with 2 children, there are 2. Similarly, families with 3 children are 1. Now, how this class interval is identified? There are 3 methods. It can be in exclusive method, it can be inclusive method, or it can be an open method. If you talk about exclusive method, it is, for example, 20 to 25, and the next class interval will be 25 to 30. And if we talk about inclusive method, it is basically 20 to 24.99, and the second class will be 25 to 29.99. And if you talk about open-ended, so it will be 30 and above. What are the guidelines which are to be kept in mind while we are choosing class intervals? Number of classes should be between 5 and 50. Number 2, the width of the class should be a multiple like 5, 10, 25, etc. And all classes should have equal width. The starting point of the class should begin with 0, 5, or a multiple. And the class interval is found by dividing the range by number of classes. We will discuss it, this fifth part, in a numerical problem. This is a data for employees of a company. And these are 50 employees. Now, the data was given to us in number, that indicates their ages. Now we have to find out which is the lowest number in this. If we talk about going back to the data, we can see that 21 is the lowest number. If This has to be converted into class intervals. So that means we will take a multiple of 10 in this case. So its first class will be 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. Because the maximum age which comes under this data is 65. So similarly, we will start with 22. We will see to the age group in which it comes. We will mark one vertical line. 20 for 21, we will again go to the first block, class, and we will mark one vertical line. We can see that there are four vertical lines and one inclined line. That means that we are representing five things at a time. This is telemarks, and these are clubbed up. So we get 5 plus 2, 7 for the age group of 20 to 30. For 30 to 40, we get 16. 40 to 50, we get 15. For 50 to 60, we get 9. And similarly to the last one, that is 60 to 70, we get 3. When we are going to sum it up, it will be a total of 50. That means all information has been collected correctly. Now, the second part, what we use, it is of cumulative and relative frequencies. These two first columns will be given to us. And how to draw cumulative frequency. This is one of the biggest part. You can see that number of employees, that is frequency, is 5, 10, 25, and 10. When we sum it up, it comes out to be 50. For drawing up the cumulative frequency, we have to write 5 in front of 5. And for the second one, we have to add 10 to 5. That means that will be 10 plus 5 will be 50. Similarly, we have to add 15 to 25, we will get 40. And in 40, we will add 10, we will get 50. And we will ensure that the last number in the cumulative frequency column and the sum of the frequencies is same. If it is not so, that means there is some error in the calculation of cumulative frequency. Now we move on to relative frequency. We have to divide these numbers so that we get their relative presence in this. That is done by 5 divided by 50, 10 divided by 50, 25 divided by 50, 10 by 50. When we sum it up, we get 1. There are two important advantages in looking at relative frequency, that is the percentage, instead of absolute frequency in a frequency distribution. They are relative frequencies facilitate the comparison of two or more than two sets of data. And secondly, relative frequencies constitute the basis of understanding the concept of probability. Now the data has been collected. We move on to second part of it, that is charting. For charting, there are 4 options which are normally used. The first one is bar diagram, second one is histogram, third one is frequency polygon, and the fourth one is ogive or cumulative frequency curve. We will start with bar charts. They are basically depicted in 3 forms. The first one is the simple one. Nowadays, we have been using 3-dimensional bar charts and stacked bar charts are used. Simple bar chart is shown over here. It has demerits. They are not being used now as such. And as far as merits are concerned, everyone is familiar with how bar charts are drawn. So to make it more good looking, they are being transformed, and 3-dimensional methods are used, or stack diagrams are to provide more information into a bar. larger. We move on to next one is histogram. This is one of the most commonly used and easily understood method of graphical representation of frequency distribution. A histogram is a series of rectangles having areas that are in same proportion as the frequencies of frequency distribution. So along x-axis we take up the class intervals and along the y-axis we take up the frequencies. There is no gap in between the rectangles. Next one is frequency polygon. It is a graphical representation of frequency distribution. It is a many-sided closed figure. Here what is done, the center point of the histograms are joined together by straight lines. And when the histogram is removed, we see this frequency curve. Now, we move on to ogives or cumulative frequency curves. An ogive is a graphical presentation of a cumulative frequency distribution. And therefore, when the graph of such distribution is drawn, it is called cumulative frequency curve or ogive. There are two methods of constructing ogive. The first one is less than ogive, and the second one is more than ogive. Less than ogive, here in this method, the upper limit of the various classes are taken on x-axis and the frequency obtained by process of cumulating the preceding frequencies on the y-axis. And in more than ogive, a cumulative frequency can be drawn by taking the lower limit of x-axis and cumulative frequency on y-axis. You can see this how this less than ogive curves look like. It moves from bottom to up. For more than ogive, it moves from top to bottom. The shape of less than ogive curve would be a rising one, whereas the shape of more than curve will be a falling one. And when these two graphs are joined together, we get something like this. And the point at which they intersect, we get the median. For getting up the median, we have to draw a perpendicular line on the x-axis, which in this case meets at 20. That means we can say that the median of this diagram or this question is 20. Now, we move on to measure of central tendency. This is here we will be using different methods for calculating mean, mode, median, quartile, etc. It is a statistical method for summarizing and describing data. We have to find one representative value which can be used to locate and summarize the entire set of varying values. Third one is central value around which the data tends to cluster. What are the significance? We condense the mass of the data in a single value to get an idea of the entire data. Example, individual income of 1,000 persons versus average income. And secondly, it is used to compare two or more sets of data. That means sales figure of August versus other months. What are the properties of good measure? It should be easy to understand, simple to compute, based on all observations, uniquely defined, capable of algebraic treatment, and not affected by extreme values. Now we will discuss what are the important measures. First one is arithmetic mean. Second one is weighted arithmetic mean. Third one is median. Fourth one is quantiles. Next one is mode. After mode, it comes geometric mean, and then comes the harmony. So we will discuss them one by one. We will start with arithmetic mean. Mean is sum of all the scores divided by number of scores. The formula is x bar equal to summation of x upon n. Or if we have frequency with this data, that means in that case, we have to we have to sum up the product of frequency and the mid value. There are three formulas, and these formulas are applied according to the nature of the data. Normally, we use the third formula in maximum of our calculations. That is x bar equal to a plus summation fd upon n into I, where a is normally what we do for the calculation purpose, and it is change in origin, and I is the change in the scale, where x bar is the population mean and n is the number of the scores, that is the frequency sum. What are the properties of arithmetic mean? The sum of deviations of the observation from the arithmetic mean is always zero. That means x minus summation of x minus x bar is zero. And the sum of the square deviations of the observations from the mean is minimum. That means summation of x minus x bar whole square is minimum. The arithmetic mean has the great advantage of being easily computed and readily understood. It is due to the fact that it possesses almost all properties of a good measure of central tendency. No other measure of central tendency possesses so many properties. However, the arithmetic mean has some disadvantages. The major disadvantage is that its value may be distorted by the presence of extreme values in a given set of data. And a minor disadvantage is when it is used for open-ended distribution, since it is difficult to assign a midpoint value to the open-end class. That means open-end means 25 and above. So we don't have the last number for its calculation. This is basically a problem here. We will see how all these computations are done. We were given column number 1 and column number 3 in the problem. We are supposed to calculate the arithmetic mean of the problem. First of all, we will find the mid value. That is, this mid value is calculated by adding 300 plus 350 divided by 2. This comes out to be 325. And to make it easier, what we will do? We will find out the difference between the class intervals, that is 300, 350 and 300, that is 50. So we will add 50 to all these mid values. That means 25 plus 50 is 375, 375 plus 50, 425, and similarly we will write it for all. Now we move on to column number 4. For column number 4, we have to calculate how many numbers are there in monthly sales column. We will find out the center one. So that comes out to be 500 to 550. In lieu of that, we will write 0 in that column. And above that, we will write -1, -2, -3, -4. And below 0, it will be +1, +2, +3, +4. Now the thing is that how this is calculated. So we can calculate, we can see that at the top it is written that x minus 525 oblique 50. That is x minus a upon d. In the fifth column, we will multiply frequency with this d. So that means 5 into 4 is -20. And similarly, we will calculate for all. At the last, we will get summation of fd, that is -60. And summation of d, summation of frequency, that is n, is 200. We will move on to the formula. Formula is x bar equal to a plus summation fd upon n into I. We will place up all these values. 525 is a, Summation of FD is minus 60. Summation of N is 200 and I is 50. After calculation, we get 550. That means arithmetic mean of this particular problem is 510. After mean, we move on to median. Median is the middle of the distribution. That means we can say that half the scores are above the median and half the scores are below the median. The median is less sensitive to extreme scores than the mean, and better measure. It is a better measure than the mean for highly skewed distribution. And for median, summation of x minus x bar is minimum. For mean it was 0 and for median it is minimum. Now the data required for median can be a series of numbers or it can be a table. If we have numbers, so if we have odd numbers, in that case the middle of the numbers, series of the numbers is the median. Suppose we have three numbers 2, 4, 7. We will arrange them in the ascending order. Order is the same 2, 4, 7, and that the center value is 4. That means its median is 4. And if we have even number of observations, suppose 2, 4, 7, and 12, and in that case we are supposed to calculate the median. So the median will be the sum of the two middle terms divided by 2. In this case, the two middle terms are 4 and 7. Sum of 4 and 7 is 11. 11 divided by 2 is 5.5. That means here the median is 5.5. If we have a tabular problem with us and we are to calculate the median, in that case we have a formula. That is median is equal to L plus n by 2 minus PCF upon F into I, where L is the lower limit of the median class, PCF is the preceding cumulative frequency of the median class, F is the frequency of the median class, and I is the size of the median class. Now the question arises, how to find the lower limit of the median class L? In that case, what we will do? We will just sum up the frequencies, we will divide by 2. We will get a number, and in the class intervals, the first column we will see to it, which is the lowest value. Then comes, after median, it comes mode. Mode is the most frequently occurring score in a distribution, greatly subject to sample fluctuations, and is therefore not recommended to be used as the only measure for central tendency. A further disadvantage of the mode is that many distributions have more than one mode, and these distributions are known as multimodal. There exists an empirical relation between mean, median, and mode, and this is mean minus mode is equal to 3 times the difference between mean and median. Or, on simplification, we can say that mode is equal to 3 median minus 2 mean. So we have to remember, because we will be using this formula for calculating the mode when we have calculated median and mean. I repeat the formula, that is mode is equal to 3 median minus 2 mean. This is also known as the empirical relation between mean, mode, and median. If we have to calculate mode for tabular form problem, in that case, we have to apply a formula which is somewhat similar to what we did in median. That is mode is equal to L plus F4 minus F1 upon 2 times of F4 minus F1 minus F2 into H or I, where L is the lower limit of the interval containing the mode. For this L, you have to find out which frequency is happening for the maximum number of times, and that is visible in frequency column. H is the H or I is the width of the interval containing the node, that means the class difference. N is the total number of respondents. F1 is the frequency of class preceding to model class. F is the number of cases in the interval containing the mode. And F2 is below the value of F. Now we have this problem. This problem will calculate. This is the problem. You have to during the conduct of the study involving a group of libraries post on library to test for find the median and mode of the mass. Now, we will rearrange this data in this form. We are given first two terms, that is 0 terms. Similarly, we calculate the cumulative frequency. In front of 45, we will get 45, then 20 to 45 will come to 65, 65 plus 40 is 20, 79 plus 7, 86, 86 plus 3, 89. So we can see that the last value in the cumulative frequency column is 89 and the sum of the frequency is 89. That means our calculation is correct. We find out the mid values, that is 0 plus 10 by 2 comes out to be 5, and the difference is 10, so we will add 10 to all. We will get 5, 15, 25, 35, 45. We will multiply F by this mid value. So we will get that last one. We will sum up 1255. Now we have to see how to calculate the mean. We know that is summation of fx by summation of f. This comes out to be 1225 divided by 89. This is 14.10. After that, we will move to calculate median. For median, we have to divide this 89 by 2. It comes out to be 44.5. We have to see that in which class this 44.5 comes. This 44.5 comes in 0 to 10 class it. For that, our L will be 0 and by 2 will be 45.5. Frequency of the above this is 0 and the frequency of this class is 45 and the difference between is 10. So after calculation, we are going to get 9.89. We are having the values of mean and median. Now we will move to calculate the mode. For calculation of the mode, we have to use the empirical formula, that is mode is equal to 3 median minus 2 mean. That comes out to be 3 times of 9.89 minus 2 times of 14.10, which comes out to be 1.47. So in a particular problem, we have calculated mean, median, and mode. Now, we move on to calculate quartiles. Quartiles are those values which divides the total data into 4 equal parts. That means it will be divided by 3 points and the distribution will be divided in 4 equal parts. The first quartile is Q1 and which states that or its value is such that it is 25% of the observations are smaller and 75% of the observations are larger. In quartile 2, that is second quartile, which is also known as median. Here 50% of the observations are smaller and 50% of the observations are larger. Then comes quartile 3, that is Q3, In this, the values are such that 75% of the observations are smaller and 25% of the observations are larger. The formula for calculating the quartile is similar to what we used to calculate the median. Here we have to calculate the quartile, so similarly we have to change, then we have to modify the formula. So Qj is equal to L plus Jn by 4 minus PCF upon F into I. For calculating decile, decile means the division of data into 10 equal parts. That means in between we will be having 9 deciles. So D1, D2, D3 till D9. So we modify this formula, what we use in, to calculate the median. Here we will modify it like dk equal to L plus Kn by 10 minus PCF upon F into I, where K will be 1 to 9. In between, we will be having 9. For percentile, the total data is divided into 100 equal parts. In between, we will start by P1 to P99. So PL will be equal to L plus Ln by 100 minus PCF upon L plus 2 I. Where L takes the value from 1 to 99. Where K will be 1 to 9. Now the method, we have to locate these quantiles graphically. To locate the median graphically, we have to draw less than cumulative frequency or less than quartile. Take the variable on the x-axis and frequency on the y-axis. We discussed earlier also. Now we determine the value of n by 2th observation on the y-axis. Now the method, draw a horizontal line from this on the cumulative frequency curve, and from where it meets the curve, draw a perpendicular to the x-axis. The point where it meets the x-axis is the value of the median. So we can see how from a cumulative frequency curve we can determine all, that is Q1, quartile 1, Q2, quartile 2 or the median, T2, P90, all these values can be calculated from the cumulative frequency curve. So we can see how. Now, when we want to mode, the mode is the typical or commonly observed value in a set of data. It is defined as the value which occurs most often or with greatest frequency. The dictionary meaning of term mode is most of these values can be calculated. We have a formula we discussed. Now we will see how this formula is used. And before moving to that, we will see how graphically locating the mode can be done. In a group data, the value of mode can also be determined graphically. In graphical method, the first step is to draw the histogram of the given data. We know how histograms are drawn. The next step is to draw two straight lines diagonally on the insides of the model class bars, starting from each group corner of the bar, the upper corner location is locating the mode can be done. And in the last step, we will draw a perpendicular which will be intersecting these two lines. On first step is to draw. So similarly, you can see that we have drawn the top corners. The next step is to draw of the middle three histograms, and the point where these two top corners coincide, we have drawn a line, and in the last step we will draw perpendicular to the x-axis, which will be this is almost at somewhere 35. We can say that the graphical, similarly we can see that graphically the mode of this data is 35. Of the middle three. The chief advantage of mode is that, and the point where these two top corners, it is by definition the most representative value of the distance. A line, for example, if we talk about the middle size of shoe or garments, we have this average in mind. Like median value of the mode is not affected by extreme values, and its value can be determined in open-end strategy also. The main disadvantage of mode is that its indeterminate value. That is, we cannot calculate its value precisely in a group data, but merely estimate. When a given set of data have two or more than two values as maximum frequency, it is a case of bimodal or multimodal distribution, and the values of mode is not
settings.
useful.
Right now,
The
we
mode
are
has
here
no
on
useful
privacy and privacy
mathematical
details.
properties.
Now
Hence,
click on
in actual
manage
practice,
activity to view
the
and delete
mode
items
is
as
more
well.
important as a
Here and
conceptual
query.
idea than as a working average. When a given set of data have two or more than two values, now we will see this relation between it is a case of bimodal mean mode or multimodal, and the values of mode is the distribution in which mean mode median coincide is known as symmetrical or bell-shaped distribution. If a distribution is skewed, that is an idea. That's not symmetric as then mode, mean, mode, median, they will not be equal. In a moderately skewed distribution, a very interesting relationship exists among distribution in mode, median. In such type of distribution, it can be proved that the distance between mean and median is approximately one third of the distance between the mean and the median. This is similar to what I said earlier. While we were talking about the empirical relationship between mean, mode, and median. This can be shown here. We can see that how mean, mode, median are related amongst each other. That means the relationship is mean minus median is equal to one third of the difference between that is mean minus median. This is how we derive of the empirical formula. This can work more shown here. Median see that is mode is equal to 3 median minus 2. How? Now we move on to geometric mean. Geometric mean is an average that is useful for set of numbers that are interpreted by their product and not their sign. That means geometric mean can be written as under root into the product of the observations, and this root will be the number of observations. That means if we have 6 observations, like 34, 27, 45, 55, 25, and 34, that means we have 6. Not what we will be doing, we will be calculating the 6th root of product of all these numbers. That means product of 34, 27, 45, 55, 22, and 34. And we will be calculating it 1/6. That means which comes out to be 34.54, 34, 27, 45, 55. When the observations are more than 3, the sightings in that case. Product of all these, the calculated purpose, that means it becomes 32, 27, 45. So in that case, when the number are more than 3, we can use and apply logarithmic relationship. In that case, now the geometric mean is equal to 1 by n into log x1 plus
Turn off the ads that appear on your YouTube channel and videos.
As you can see on this video, I've got a pre-roll ad that's playing before my video. Click on your profile icon, click Create a Studio,
Geometric mean
Click
is
Channel.
specifically useful in the
click Advanced.
construction of
Under
data.
Advertisements, uncheck the box that says Allow Advertisements.
When large weights have to be given to small weights of observations and small weights to large
As you
weights.
can see on this video, I've got a pre-roll
This
ad
average
that's
is
playing
also
before
useful
my
in
video.
measuring the growth of the population.
Click on your profile icon,
Now we
click Create a Studio.
calculate harmonic mean.
Click channel.
Harmonically,
Hi, this video is about how to turn off
Advanced. View my profile icon. Click Create Studio. Click Channel. Click Advanced. Under Advertisements, uncheck the box that says Allow advertisements to be displayed alongside my video.
X bar equal n upon summation of all the numbers, and these numbers calculate harmony. 1 upon 4. We can see this formula over here. Suppose we have again 6 numbers, that is 34, 27, 45, 55. That means which we have to calculate this particular.
दोस्तों YouTube पे फिर से एक नया अपडेट आ गया है जिसका नाम है स्टॉप एड्स, और आज के इस वीडियो में इसी अपडेट के बारे में आपको फुल एक्सप्लेन करके बताऊंगा।
Plus 1 by 36, plus 1 by 45, plus 1 by 55. So we get 33.0. We can see this formula over here. Harmonic mean is useful for computing the average rate of increase of profits or average speed at which a journey has been
दोस्तों YouTube पे फिर से
or
एक
the
नया
average
अपडेट आ
price
गया है
at which
जिसका
an
नाम है
article
स्टॉप
sells.
एड्स, और आज के
Otherwise,
इस वीडियो
its
में
fields of
इसी अपडेट के बारे में
applications
आपको फुल
clearly
एक्सप्लेन करके
1 by
बताऊंगा।
34, plus 1 by 37, plus 1 by 45, plus 1 by 50. Now we move on to how to measure the variation and skew, the average rate of increase of profits. What is the significance of measuring variation? Measuring variation is significant for some of the following purposes. Measuring reliability determines the reliability of an average.
You often get distracted by ads that play before a YouTube video? Yeah, go ahead. I'm just doing a video here. Channel or on individual videos from
Studio.youtube. Click on YouTube Studio Beta or go to studio.youtube.com. Select the individual videos where you want to turn off monetization. For example, these videos, the monetization has been turned on. You can see the green dollar sign. It says this video.
Of 2 or more distributors.
You often get distracted by ads that play before a YouTube video? Yeah, go ahead. I'm
What
just
are the
doing a video
properties
here.
of good meter?
Channel or on individual videos from
It should possess, as far as
YouTube Studio
is the
Beta
same
or studio.youtube.com. Select the individual videos where you want to turn off monetization. For example, these videos.
Following are some of the
monetization
well-known
is turned
measures of
on.
variation
You can see the
provide
green
a
dollar sign.
numerical index of the variability of 2 or more distributors. Range.
You often get distracted by
Number
ads
2,
that play before
average or mean deviation. Number 3 is right deviation or semi-interval range. The fourth one is standard deviation. We start with range. Our data is given to us. Suppose we say that we have numbers like 2, 3, 4, 5 from 2 to 10. That means there are number 2 average or mean deviation. Number 3 is high numbers as such. And we have to calculate the range. So range is basically the difference between the highest value and the lowest value. Here the highest value is 10 and the lowest value is 2. That means its range is 8. The range is the simplest measure of variability to compute. However, it does not use all of the data. As the sample size increases, the range can increase, but the range can never decrease. Now we will see how. For example, here the highest value is numbers like 2, 3, 5. The lowest value is the lowest number is 2. That means its range highest number is 10. The range. Now if you take our earlier problem that was 2 to 10, all numbers from 2 to 10 comes the range is 8. And the sample size, the range does not have any information about the nature of the range. Can we never decrease? Now we will see how. Now we calculate the coefficient of coefficient is the highest value, the ratio like 2, 3, 5, the difference between the highest and the lowest value to the addition of highest and lowest. Now the range does not have any information about the nature of range. Quartile deviation is also known as semi-quartile. Now we calculate and is computed by taking the average of the range between the third quartile and first quartile. That means QD is equal to Q3 minus Q1 by 2. Q3 is third quartile and Q1 is first quartile. What is how to calculate the coefficient of quartile deviation? The relative measure corresponding to quartile deviation is the coefficient of quartile deviation. It is defined as Q3 minus Q1 upon Q3 plus Q1. Quartile deviation is superior to the range and is not based on the extreme values, but rather on 50% observations. Another advantage of quartile deviation is that it is the only measure of variability which can be used for open-end distribution. The disadvantage is that it ignores the first and the last 25% of the observations. Then comes average deviation. The measure of average deviation is an important over the previous two measures, as in that it considers all observations in the given set of data. This measure is computed as the mean of deviations from the mean or the median. All the deviations are treated as positive regardless of the sign. That means average deviation is summation of x minus x mod of summation x minus x bar upon n. If for mean it is x minus x bar, and for median it is x minus median upon n. There is an advantage in taking the deviation from median because the sum of absolute values, that is, ignoring plus and minus sign, the median is mean. In actual practice, however, arithmetic mean is more popularly used in computation of average deviation. The relative measure corresponding to the average deviation, called the coefficient of average deviation. If average deviation has to be computed from median, the coefficient of average deviation shall be obtained by dividing the average deviation by the median. So it is the coefficient of average deviation is the ratio of average deviation to median. This conclude to the today's session, and if anyone has any question, please ask, and we will continue in our next session after this.